Hi, I'm Dory, and this is Ask Starbase. Today we are looking at questions related to sea creatures submitted by students from the Jamoke Honors Conservatory. First, Ken Kaneki wants to know, do sharks have a protective layer on their skin? Yes. Sharks have scales called denticles, which actually look like layers of teeth under a microscope. They grow from the skin, and the visible part, known as the crown, often ends in a pointed tip angled towards the tail. A shark's skin is incredibly smooth if you rub it from the front to the back. But if you go against the scales, it's the complete opposite. The ancient Greeks actually used shark skin to smooth wooden objects the same way we use sandpaper today. The scales protect sharks from obvious dangers like sharp pieces of coral, rocks, and litter, as well as serving as the first line of defense against a variety of ocean parasites. That being said, some shark scales are designed more to help them move quickly and easily through the water, like you might see in a hammerhead, than to serve as protection, which is what we often see in tiger sharks and nurse sharks. Kiyoya Tatagami asked, how do deep water fish survive in the deepest parts of the ocean without getting crushed by the water pressure? Creatures who live in the deepest part of the oceans have evolved to adapt to what we would consider a hostile environment. The pressure levels in the sea range from 20 atmospheres to over 1,100 atmospheres. In other words, 20 to over 1,000 times more pressure than we experience due to the air in our atmosphere. This pressure is so intense that it would crush air pockets, like those found in fish swim bladders, instantly. Fortunately for deep water fish, this pressure is unable to crush water in the same way. A small portion of these animals have swim bladders, like those found in fish who live in shallower areas. Fish use their swim bladders to control their depth by controlling how much gas is inside of it. Deep water fish with swim bladders are less common, but still highly adapted to handle the immense pressure from the ocean. However, if the animals are removed from their normal habitat, the gases inside will expand, killing the creature. Other species have evolved so that their swim bladders are filled with oils instead of gas, and others don't have a swim bladder at all. Fish living in deep waters also tend to contain a lot of water inside their bodies and have thinner skeletons. These adaptations make it easier for their bodies to match the pressure inside their bodies with the pressure of the water outside of them. While swim bladders may be optional, biomolecules, or the molecules related to life, are not. Scientists have discovered 2 ways deep sea life are able to withstand pressure on their biomolecules: the membranes, or outer layers, of cells, and many proteins have built-in pressure resistance. The scientific community is still working to understand how these structures work. We do know that this means these biomolecules work great in these animals' regular habitats, but they will fail in environments with lower pressure, like shallower places in the ocean. Aside from these specialized biomolecules, some fish may use molecules known as piezolites, which are small molecules that keep the pressure from impacting larger molecules. You may have smelled one of them before. Trimethylamine oxide, or TMAO, is what gives that fishy smell to shrimp and ocean fish. This compound is found in fish from shallow habitats that humans will eat, but the levels are much higher in their deeper dwelling species. Thank you for joining me for this episode of Ask Starbase. If you have a STEM question like Ken Kaneki or Kiyoya Tatagami, please email it to us at ask@starbase-ct.com or go to our website, starbase-ct.com, and scroll down until you get to the Flipgrid. Stay safe and be well. Bye.